Ugh. Hi, Deborah.
Hello.
Tiara, you there? Are you in an upstairs room, Deborah?
Yeah, I'm in an apartment, so yeah.
Oh, okay. I see high trees there. That's why I wonder.
Oh, yeah.
Okay. Hey, Tiara. Okay. Let's see.
I have a question about one of the questions on the quiz.
Okay. What you got?
It's
Tell
the
me.
third, huh?
Go ahead.
It's the third section, letter C.
Oh,
Tell me
yeah.
what it. Tell
That's
me
the
what it
only.
is.
It's where we had to determine the nth term.
Okay. What's the sequence?
2, 5, 8, 11, and 13.
Uh-huh.
That's the only one I couldn't get.
Okay.
Don't-
3, 3, 3.
And it don't work at the
Ooh.
end.
You know
see?
what? It doesn't work at the end. I think
Yeah,
I might have made a typo on that. If you had to guess that one, it would be 14, wouldn't it?
Yeah.
Let's change it to 14.
Okay.
Okay.
That's
That's my fault.
I just thought I wasn't seeing something. I was like,
No, I mean, if it was, there might be something there, but it's harder than I wanted it to be. Let's just put it like that. Okay. So 2, 5, 8, 11, 14, and then you can see the pattern.
Okay, thank you.
Okay. Okay.
Yeah.
All right. Okay. You guys got any other questions while we're waiting for Dion and Alexis? Does the quiz otherwise look okay? I think.
I mean, it was another one, but I think I got it right.
Okay.
But I did a lot.
Was it one of the limits?
Yeah. I mean, yeah. I used something from the previous section. Maybe it's right. I don't know.
Which one was it? Tell me which one it was.
Letter D.
And tell me what it says.
1 plus 2n, and then all of that to the 2n.
Oh. Okay. Let me ask you. Tell me what you used on it, just out of curiosity.
I don't want to pronounce it wrong.
L'Hopital.
Yeah.
That's what you used. That's good.
You had to bring down the 2n, and then I put it over that.
If you think about these things as just regular functions, so 1 plus 2x to the 2x, what we said, if it works on a regular function, it'll work on this sequence term. So if we'd had that on the last test, you would have done, that's exactly what you would have done with it. Okay. You would have used the L'Hopital's rule on it. Okay.
Okay.
There's a little more you would have to do, but that's fine. That's what you should be doing. Okay.
Okay.
Okay. Anybody else? Deborah, you okay?
Well, I just thought that was 1 plus 2 over n.
Look at it again, Tiara. Which one?
I mean, that's how I mean.
Maybe I did it wrong. I don't know.
No.
And then all of that was raised to the 2n, correct? Or did I read that wrong? Maybe I read it wrong. Maybe I made it more complicated.
Let me see if I got the quiz in here. Hang on. Let me see if I got the quiz up here. Partial fractions, sequences quiz. I don't see it. It'll work a similar way either way. If it's, are you guys both seeing the same question? Is it 1 plus 2n to the 2n or to the 1 over 2n?
No, I got 1 plus 2 over n and all of that to the 2n.
Yeah, same.
Oh, okay.
Oh, okay. Forget it. You got it. It's okay.
Okay.
All right. It's fine. Okay. Anything else?
No, those were my only two things.
Okay. All right. So go ahead and get it to me. I'll get it right back to you.
Okay. I need like 2 minutes.
To give you another quiz, but it's not due Monday, so we don't.
Alexis said she's waiting for you to let her in.
It didn't ding at me. It's supposed to. The doorbell's supposed to ring. Whatever.
Yeah, she says she's been trying to get in.
She's here. Okay.
Okay.
Sorry, Alexis.
Be right back.
Your doorbell didn't ring. My doorbell didn't ring.
You're
so
welcome.
Anyway, but you're here.
Dion said she told me her computer just restarted.
Okay. So if she's restarted, I'll look for her to come in and we'll see. Y'all remind me of that. Okay, so Alexis, we were just chatting about the quiz, and there's something on the quiz I need to change to make a problem easier. I didn't intend to make it quite so hard. On the ones where you're supposed to write the nth term, those that you like, the sequence should have been 2, 5, 8, 11, and 14 instead of 13. So that last thing should have been 14 instead of 13 on there. That'll make it a lot easier to do.
Which number is this one?
It's on the quiz, and it's one of the last, in the last section where we had the sequence and you had to write the nth term. It should be 2, 5, 8, 11, and 14.
Okay.
Was it C? Tara and Deborah, was it C? 3C?
Mm-hmm.
Okay, 3C. So you seeing that, Alexis?
When I do it,
Okay, well, you don't have to suffer with it, okay? It was hard. When I had a 13 there, it was hard. Now I put a 14 there, you should be able to fix it, okay? Okay. All right, anybody else got a question? So,
yeah,
yes,
I have
Alexis.
a question about the homework that I did.
Okay. So tell me the page it is and tell me the problem.
The rubber ball problem.
Mm-hmm.
Yeah, yeah.
All right, hang on. Let me let
messed
let me
up.
let Deanna in. So that was 55 on page yeah, 542, 55. Okay. So let's draw a picture of it first. Let me see. Let me share the screen. I'm waiting everybody to get in here, and we'll look at that one. Okay. Let me see if I've got any extra pages on any of these documents. Let's see. I'll just open up the one I'm going to do today, and then we'll. Let's see. Let's go all the way down here. Okay. I'm gonna write it right in here, and then I'm gonna erase it because that's something about my quiz. Okay. So this is that problem about the bouncing ball. It was 55. It says a rubber ball is dropped from a height of 10 meters. It rebounds 1/2 the distance after each fall. So if I'm drawing a picture here, it's coming from a height of 10. So, all right, so it's going that way. So we'll say that first element there is 10. All right, so it comes down 10. And actually, guys, I'm drawing it kind of like this, like this going down, but they're really just bouncing it up and down. So it is the height right there. Of course, that curved height would be higher than that, but that's not what I mean. It's kind of looking like the following. First of all, the first amount it falls is 10. And then it says the next is 1/2 of that. All right, so the next fall, whatever, is 1/2 of that. So plus 1/2 of 10. And the next fall is going to be 1/2 of that. So 1/2 of 1/2 of 10. And what you see happening is you're getting something that looks like it's got all these powers of what in it. I mean, all of them clearly have a 10 in them. So if I pulled out the 10, I'd have 1 plus 1/2 plus 1/2 squared plus 1/2 cubed and so on. But let me say something here. If it comes down from a height of that, it's got to bounce back up. Okay, so it's got to come down from that height. So you've got another one of those. You got this and this twice, and then this and this twice. The only one you have once is this first one. So it's actually 2 times the rest of them. Okay, because it's got to go up and down. All right. So it bounces up, it's got to come back the same distance down. Then it bounces up halfway, comes back the same distance down. So see if you can write that every jump. So if we just say this is the first one, second and third will be the same, fourth and fifth will be the same, and then you can look and see if you've got it. It's going to end up being a geometric series. Okay. Try it again and see what you get. And I'll give you the answer to that one when we come back on Monday. Okay. The only one that gets a one-time bounce at whatever height it was is where you drop it from that height. and you go up, and the same back down, up, back, and then so on and so forth. Does that make sense? Your question, Alexis.
I just feel like this stuff is just getting mixed up in my head. So I get confused so easily.
Well, it's because it's new.
I have to like pay attention because sometimes I don't know what I'm solving for.
Yeah, and the more we do some of these, I think the easier it'll get. But right now, to recap, what we got are some important series. There's a geometric series. We've got telescoping series, and now we've got P series, and I'm going to talk more about P series today. So what you're going to want to try to do in any of these problems is decide what kind of series it is. And because every one of these things gets multiplied by half every time, I'm thinking, well, that's the R. Remember what happens in a geometric series? It gets multiplied by the same thing every time. So that's what tips me off to the fact that this is a geometric series. Okay. So figure out how much that is, that, and so on, and then find the sum. And what you need to remember about a geometric series in this problem is that the sum is A over 1 minus R. Now I'll ask you a question. Whatever we do, I mean, if we were to look at just this piece of it, which is a little more than half of it, first of all, you could pull the 10 out if you wanted to, but then you identify your A, and it looks like the R is going to be 1/2, definitely, because it's coming up a half the distance every time. So rewrite it, and I'll look at the key. I'll either send it to you this weekend, or we'll look at it on Monday, okay? And then we'll see if we're getting the right answer. Anybody else anything in the homework? Okay. What I want to, let me get rid of this because it's all over my lecture now. What I want to do is review again something we learned on Thursday. The thing that makes this stuff stick, guys, is doing a lot of problems. It's like integrals. You get better at them the more you do, because you know you can look at it and say, oh, I need this, oh, I need that. This is the same kind of thing. But let me show you one other thing before I go on. I'm gonna give you a quiz to take home over the weekend, and it won't be due until Tuesday, okay? But I want to show you how I've written it out, and I think this will help you to sort of sort your thoughts out about these things. I typed it up, and then I thought I lost it, and then I found it, and anyway, it's typed up, but it's not typed up great. It says, for each of the series on the next page, determine whether it converges or diverges. Each conclusion should be supported by a theorem, technique, or a result from 11.2. A mere converges or diverges answer will not be sufficient. You got to tell me why it converges. It's a geometric series with R equal to this, or it's this, or it's that. Guys, this is only from 11.2. It does not include P series. All it includes is telescoping series, the harmonic series, the nth term divergence test, and geometric series. So you get those fixed in your head before we start, doing more things. Now, let me give you some examples. If I looked at this series right here, 1 over E to the 1 over N, and I say, does that diverge or converge? Now, it's not going to be geometric. I think if you were to write out some terms of the sequence, you wouldn't see a way you could get from one to the other. And by the way, this N, as N goes to infinity, should have been under there. And this one should have been under there. The very first thing you're always going to want to try is this thing called the nth term divergence test. Because if the limit of this thing right here does not go to 0, you're done. It diverges. Okay, it diverges. So that's what I always look at first. If I look at this and I'm going to infinity, notice 1 over N, if N's getting bigger and bigger, what's 1 over N doing, guys? Where's 1 over N going if N's getting bigger and bigger? 0. So what we get is 1 over E to the 0, which is 1. Notice that 1, and oh man, my beautiful typing job, I messed up something. It's not 0, therefore it diverges. If you take the limit of that thing and it's not 0, if it's not 0, it cannot converge. If you get 0, you have to look at something else.
So like the nth term, we're just looking at the limit of the thing.
Yes, you're just looking at the limit of the nth term. I'll give you another one in a minute, but that's what that, if you look at the limit of that thing and it is not 0, all right, then what happens is that you've got a problem. It will not diverge. I mean, it will not converge, it will diverge. Now, look at the next example. 0.27, if we think about the nth term divergence test on that, is 27 over 100. And back in 11.1, we said if R was less than 1, that thing to the nth went to 0. So this one goes to 0. But then it just tells me it may still converge. Does everybody understand? If it doesn't go to 0, we can say it diverges. But if it does go to 0, anything can happen. So that one clearly goes to 0. So using the nth term divergence test tells me on that one, well, it has a chance to converge. But if you look at it, if you look at this thing, get rid of that. I think if you look at some terms of it, you'll see we're raising 27 to the nth power. So if you look at that, it's 0.27. If you plug in 1, if you put in 0.27 squared, it's 27. I'm sorry, 0.27 times 0.27, 0.27 squared. All right, another 0.27 squared. You see something's happening. I mean, how can you get from one to the next if all of them are 0.27 and they keep getting higher there, guys? I mean, what kind of series is that?
Geometric.
It's geometric, where A is 0.27 and the R is also 0.27. And what we know about geometric series, if R is 0.27 is less than 1, it converges. So what I want you to tell me is I want you to give me an answer and tell me why. Okay, give me an answer and tell me why. Now, let's look at another one. Look at this next one. If you look at 4 over 5 to the nth, I think if you look at some terms of that, you'd get 4 plus, well, let's look at it. I think we've already looked at this one. If we looked at some terms of that, we get, if we let n be 1, we get 4/5. The next one would be 4 over 5 squared. The next one would be 4 over 5 cubed. Sorry. Is that geometric? 4 over 5, 4 over 5 squared, 4 over 5 cubed. Is that one geometric? This is a square right here, guys. Can you get from this one to this one?
Yes.
What would you multiply by?
1/5.
1/5. Is 1/5 going to take you from that one to that one? Yeah, it's going to be 4 over 5 cubed. The next one will be 4 over 5 to the 4th. It's geometric with R equal 1/5. And that's less than 1. And it could be negative, guys. This could be an absolute value here. But it's less than 1. So that means that one converges. But then you got this one. What do you know about 3 over n?
Harmonic.
Say it again. Yeah, it's I heard it, I think. It's harmonic, isn't it? We could bring a 3 out, but multiplying by a constant isn't going to change what happens to the harmonic series. What happens to the harmonic series?
Goes to infinity.
That term goes to 0, but the sum goes to infinity. You're right. So the harmonic series diverges. So that one is a divergent harmonic series. This one's a convergent geometric series. We had a theorem that said the sum of a convergent and a divergent is divergent. But sometimes you have to look at both of them. If both of them diverge, it'll diverge. If both of them converge, it'll converge. But if you got one of each, it's going to diverge.
So this is how do I say this? These are the possibilities.
Yes.
Okay.
These are all the possibilities.
It seems like the possibilities are endless.
Guys, well, no, they're not endless yet. Okay.
Oh my God.
Because in this section, you just got, things about harmonic series, this nth term divergence test, and geometric series. You also know some telescoping things and some things about telescoping series. So look at this next one. I wrote 1 over n plus 4. Does the limit of that as n goes to infinity equal to 0?
No.
Well, I don't know. Look at it.
I don't know. I just.
Yeah, well, look at it. That's my first test. This has to go to 0 to give it a chance to diverge, to converge. So 1 over n to the 4th. If n gets bigger and bigger, where's that thing going, guys?
Zero.
As n goes to infinity, it's going to go to 0. Now, if it hadn't gone to 0, I would immediately say it diverges by the nth term divergence test. But it goes to 0, so it has a chance to converge.
Converge.
But look at this though. But look at where it starts. 1/5, 1/6, 1/7, 1/8. You know what? That looks like what series to me? It looks like a piece of what series?
Harmonic.
Well, the harmonic series. And what we said yesterday is if it starts looking like a series after a few terms, it's going to do the same thing. So the harmonic series diverges, that means this diverges. And I put down there the theorem that I'm looking at there. And this will make you look back at the theorems and see what they say. Okay? It's just the tail end of the harmonic series. It's going to diverge.
So harmonic series always diverge?
Yes. The harmonic series is, look, the harmonic series is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 and so on plus 1 over 6. And what we have here is sort of that part of it. Well, that's the infinite part. You know what? If the whole thing, if that thing diverges, throwing away those few terms right there is not going to make it converge. Okay, it's still going to diverge.
So with geometric series,
That's not geometric. Oh, ask me about geometric.
yeah, do they always converge?
Geometric series converge when the R you find is less than 1.
Oh yeah, yeah.
That,
See, I'm trying to remember these
I know.
things.
You know what you need to do? You need to go down, you need to go and look and write down the test that you got right in front of you, okay?
What?
So here's where the geometric series converges. Geometric series converges if the absolute value of R is less than 1. It diverges if the absolute value of R is bigger than 1.
Okay.
Is bigger than 1. Bigger than or equal to 1.
So we said the nth.
This is for geometric. That's where it will converge. That's where it will diverge.
How many series do we have? Like, I just don't I know we got the harmonic.
We got the harmonic series. We got geometric series in general. We got telescoping series right now.
Geometric, telescoping.
Yeah. So, guys, when you're studying this, make a cheat sheet for yourself. It'll help you when you take the test. I mean, you guys believe this is a big benefit you got doing these tests open book and open notes. Normally, I'd be making people memorize all this stuff, and you wouldn't have an open book and you wouldn't have open notes, okay? So make yourself a cheat sheet of what you need to know, okay? And then you can look at it, okay? I mean, organize it however you want to organize it. Look through my lectures, look at what I've done new, write it down, rewrite it, okay?
Is the M term a series?
Is what?
Is the M term a series?
The nth term is this thing right here, is what you're taking the sum of.
I'm
So-
talking about like when we did the M term test, was that a series?
The nth term divergence test says this thing right here, this is called AN. That thing right there has to go to 0 for this thing to have a chance to converge. If it does not go to 0, you can say immediately that the series diverges. Let me give you an example, another example. You look through my notes, you're gonna see examples. If I said the sum from n equal 1 to infinity of 2n squared plus 1 over n squared, and I said to you, does that diverge or converge? The first thing I'm going to do is look at the limit of this as n goes to infinity. We know how to do that from Calc 1. What's the limit of this as n goes to infinity?
2.
2.
It's 2, that's right. And 2 is not 0, therefore, this thing diverges. If you get one of those, if you take your AN and you take a limit of it and it's not 0, it's going to diverge. If it is 0, you just have to do something else on it. It has a chance to converge, but you got to figure out why.
See, I think I'm just trying to organize this.
That's a good idea. That's a good idea, okay? Yeah. So, guys, get me the sequence quiz, and then this quiz, and this should not be too hard. I mean, some of these you can just look at, and you can tell they're geometric, or you can tell they're whatever. But I've got 10 problems on here, okay? And I want you I've got 11. The last one is find any one of the geometric series and find its sum up there. So you're going to be looking at these things and trying to decide whether they're geometric, whether the nth term is non-zero or whatever. The other thing, most of them, as I look at them, they're mostly geometric or harmonic. Okay. All right. So, okay. That's what that quiz is on. It's going to be due on Tuesday. I don't want you lagging far behind in some of this stuff, okay? It's going to be due Tuesday. So if you have questions when you look over it this weekend, answer the questions, see if you can justify what you're saying, and then we'll talk about it Tuesday if you have any questions. All right. Is everybody clear on that one? So send me the sequence one and then start working on this one. Okay. So the next thing I want to do is remind you of something we did yesterday. We added a new test yesterday. Hear me again. We added a new test. It is not on this last quiz, okay? It's not on the quiz. It was called a P-series. This should go front and center on your cheat sheet, okay? If it's a P-series and you got 1 over n to a power, this will converge if P is bigger than 1. It will diverge if P is less than or equal to 1. Take 1, for example. If you put a 1 in for P, 1 over n is the harmonic series. I know it diverges. So it's going to diverge. If this were 2, your P would be bigger than 1, so 1 over n squared is going to converge. It's an easy test. You just got to recognize what this thing looks like, okay? If I had this one, and I'm going to use this one again here. Suppose I had the sum of 1 over the square root of n. Guys, that's a P-series. What's the power on n in that problem?
1/2.
1/2. Is P bigger than 1 or less than or equal to 1? Less than or equal to 1. 1/2 is less than or equal to 1. This series diverges.
So we would say diverges because
P is less than or equal to 1. That would be your reason. That would be your reason. Okay? So we're going to be working with these a lot today. We're going to be working with this thing, but it's a new test that you have. That's the only new thing we added there. Now, this is in section 11.3, and you usually don't get series that are really this nice, but maybe I'll throw one in that's kind of a gimme, and you figure out what P is, and you can look and see whether it converges or diverges for that value. That's an easy one. What happens here is that a lot of times we have more complicated functions that we want to see whether they diverge or converge. So what we're going to do is get a test, another test. And it's actually a pretty simple test if you learn how to use it, but it takes a little practice. It's something called the basic comparison test that I'm going to refer to as BCT from now on, the basic comparison test. It says if we let AN and BN be positive term series, if BN converged and every term in AN is less than every term in BN, then for every positive integer n, AN will converge. Now let's just write it. Let's write it down, guys. Write it down and then I'll talk to you about how it works and why it works. Okay, AN and BN are positive term series. If BN converges and everything in A is less than the things in BN, then AN is going to converge. Okay, so if we look at this sequence right here. So I'm sorry, this sequence series right here. Clearly, if you take the limit as n goes to infinity, the denominator is getting bigger and bigger, so that's going to 0. So it has a chance to converge. You always want to try to do that first, okay? So as n goes to infinity, that's going to 0. We're in good shape. Okay. The question is, can we compare it to anything we know? I'm gonna look at something here, guys. I'm gonna look at the denominator for a second. Well, before I do that, let me do one other thing. Will everybody agree with me that 2 is less than 3? This is not a trick question. 2 is definitely less than 3, okay? What if I take the reciprocal of these? Now which one is bigger? The 1/2 is bigger, isn't it? Anybody agree with that? Because if you put a bigger number in the denominator of a fraction, you get a smaller fraction, right? So if I know that 2's less than 3, then 1/2 is bigger than 1/3. I flip it. If I find the reciprocal here, the less than changes to a bigger than. Does everybody agree with that? There's not a whole lot to look at there. If you put a bigger denominator in a fraction, you got a smaller fraction. Okay? So here's why I told you that. Suppose we looked at the denominator of this thing right here. 2 plus 5 to the nth. I'm just going to look at that. And then let's look back at the series for a minute. What if that 2 wasn't there? What kind of series do you think this would be right here? What would 1/5 to the nth be? 1/5 to the nth. Well, I've got 1/5 and the 5 keeps getting raised to higher powers. What do you think this is?
The geometric.
Yes, it's geometric. And the r turns out to be what? What do you think the r is to go from one term to the next?
A fifth.
A fifth. You can write it out if you want to, but you can pretty much see that there. So does it converge or diverge? Just if you look at if r is less than 1, it converges. Good. So if I had that, I could do this problem. I mean, it's the 2 in the denominator that complicates things. Okay? So, but what I'm going to tell you is this. I'm going to say, well, you know what? 2 plus 5 to the nth is bigger than 5 to the nth. Everybody agree with that? I mean, if I got 5 to the nth, and I add 2 on one side, it's going to weight more on that side. Everybody see what I'm doing there? I'm kind of comparing it to something I wish it was. And now if I look at the reciprocal, I get this. Notice that when I flipped it, that didn't come out very well. Hang on. That's 2 plus 5 to the nth is less than 1/5 to the nth. Notice here, you can also read that by saying, well, that's a bigger denominator, so it's a smaller fraction. That's a bigger denominator. Adding 2 would be bigger than that, so it's a smaller fraction. Now, here's why that's important in this thing called the basic comparison test. Because now you can compare this series to that series. And what this test says is this. If everything in this one is less than everything in that one, and that one converges, then that one's got to converge. If you know something's bigger than something and that thing converges, something that's less than, it's always going to converge. Think about it like this, guys. If this thing has a sum, something less than that's also going to have a sum.
So when we're doing it, we're really looking at the thing that has the n.
Yeah, you're kind of looking at something you would wish you were dealing with because it would be an easier problem, but then you can set up the comparison test. All right, so what we've got here is what we call the basic comparison test. And we're going to say that this series right here, in a sense, 1/2 plus 5 to the nth, all the terms are less than 1/5 to the nth, okay? And this one converges because it's geometric It's geometric, and its R is 1/5. Okay. What this is saying is if a convergent series dominates, it's bigger than, dominates another series, then the one under it has to converge. Okay. Now, guys, if this diverged, it wouldn't help me at all because something bigger certainly might diverge than something smaller, okay? But if you got something smaller than a convergent series, anything smaller than that is also going to converge. That's what this says.
Do we have to write the n equal stuff anymore?
Yeah, you know, that's a good question because sometimes books will leave it off. And sometimes we don't always start it at 1, but technically, yeah, it's probably not a bad idea to write it, okay? That's a good question. Does everybody see what I say? If you've got a dominating convergent series, anything less than it's also going to be convergent. So I needed to set up this idea here to figure out what happened. Okay, let's look at another example. This next one. This next one's a little bit funky. It's even funkier than the other one. But what you're going to want to do on a lot of these problems, guys, is look at those two things that are the highest powers in the numerator and the denominator. And then ask yourself, can I compare it to something that this might be less than? Well, again, I'm going to just look at this square root of n thing here. The square root of n over n squared plus 1. And I contend that that's less than the square root of n over n squared. Well, why is it? Because this is a bigger denominator than that, right? I didn't change the numerator, guys. This is a bigger denominator. If I got a bigger denominator, I got a smaller fraction. Got to make that connection in your head. Now, if I can, let me erase this because write it again. If I can show that that series right there converges because it dominates that one, then that one will converge. So let's look at the series from n equal 1 to infinity of the square root of n over n squared. If I can show that thing converges, then this will converge because that series dominates that one. All right, now here's what I want you to tell me. That doesn't, at least in its present form, it doesn't look a lot like the series we've been dealing with. Could you simplify this anyway, guys, to make it look a little better? Could you simplify the square root of n over n squared?
Yeah.
Yeah, how?
It would be 1 over n to the 2 or 3 halves.
Okay, so what Deborah's doing, I think, is she's looking at powers of n there. So let me just rewrite it. N equal 1 to infinity. That's n to the 1/2 over n squared. And that's the sum from n equal 1 to infinity as 1 over n to the 3/2. Okay, in other words, I'm comparing this series to that series. I'm comparing this series right here to that series, and I know it's less, this one is less than this one. Can you tell me what that kind of series that is? What kind of series is that? 1 over n to a power? What is it?
P.
P series.
Okay.
P series. And when do P series converge? This is P series converge when P is bigger than 1. Is that bigger than 1? Yep. That thing converges. Therefore, this converges by the basic comparison test. Now, guys, what's happening here is, and the way you're going to do these problems is you're going to try to find one that you can figure out what it does. Okay? And when you figure out what it does, whether it converges or diverges, and you get it to dominate something else, you can say, well, since this one converges, then one less than that one converges. So I would show my comparison right there. And I would say, since it's bigger than that, it converges by the basic comparison test because this is a P series that converges. So you have to tell me why this converges, and then say, because it's bigger than this, and it converges, then the whole thing converges. All right, let's look at another one. This one is a little bit messier, but remember, you want to compare things to things you know about. You want to compare things to geometric series and p-series. This is a little harder, but let me show you what the term. Let's look at what the terms of this one look like. Let me get rid of it. The first term will be 1 over 1 factorial, so that's 1 over 1. The next one will be 1 over 2 factorial, so that's 1 over 2. 1 over 6. 1 over, let's see, that's 2 times 1, 2 times 3. 1, 2, 3, 4. 1 over 24. That's what that looks like. We've looked at that before. That's what that looks like. So we need to compare it to something we already know. And the way I'm going to try to compare this is look at those denominators. And we need to compare it to something that's simple. Maybe like a p-series. Can you see a p here that's always going to give you a smaller thing in the denominator? Now remember, a smaller thing in the denominator means a bigger fraction. That started with a 2. This takes a little bit of practice, but suppose I said now 2 squared, 2 cubed, 2 to the 4th. 2 squared is going to be bigger than 6. 2 cubed, 2 squared is going to be less than that. 2 cubed is going to be less than that. 2 to the 4th is going to be less than the next one. The next one's like 120, okay? So what we've got in this series right here, 1 plus 1/2 plus 1/4 plus 1 over 2 cubed, is going to be bigger than that because its denominators are smaller.
So
what does this look like? What does that look like?
That right there, that's
looks like 1 over 2 to the nth power, doesn't it? Doesn't that look like 1 over 2 to the nth power? If we we start at n equals 0 or wherever. What kind of series is that?
p-series.
That's not a p-series. If it were n squared, I agree with you.
Oh.
Geometric.
That's geometric, okay?
Why are we doing that though?
Because I want to know, does it converge or diverge? What's R? What's R, guys?
1/2.
R's 1/2. This thing converges, and it's dominating that one. The terms here are bigger. 1/4 is bigger than 1/6. 1/8 is bigger than 1/24. 1/16 is bigger than 1/20. It is dominating this thing. So if it dominates it and it converges, which it does, then we know this converges.
I just think I'm confused on why we did the geometric sequence.
Because I need something to compare this to that I know what it does. That's exactly why I'm doing that.
Oh, so it's just something, okay.
It's something to compare it with, and if you know that it will dominate the one you're looking at, and the one you pick, this easy one converges, then the one it dominates converges. You just sit somewhere in the quiet, dark, think about that, okay? You want to find a series that's easy to tell whether it converges or diverges. And if this thing converges and it dominates that, then that's going to converge.
That's geometric.
That's geometric. So for that reason, this is geometric. It converges. Geometric. It converges. And it dominates this. It dominates this. Its terms are bigger. So if a convergent series dominates a series, it will also be convergent. All right, another part of the theorem. The second part of this theorem says if Bn diverges and An has bigger terms than Bn's for every positive integer n, then An has to diverge. Now, in other words, guys, if this thing diverges and you can compare it to, and it's less than the one you're looking at, then it's something divergent and you got something bigger, the bigger thing's going to diverge too. So if you have a diverge on the lower end and it's less than that, then that's got to diverge too. So if you can find something on the lower end that diverges and your thing you're looking at is bigger, it's got to diverge. All right, let me give you an example. Look at 3 over the square root of n minus 1. If I look at that thing and I take that 1 away, that'll be something I might be able to handle. And we'll talk about what it is in a minute. But I want to know which fraction's bigger. Is this fraction bigger or that fraction bigger? Which one has the smallest denominator, guys? The smaller denominator.
The
The n minus 1.
The minus 1, exactly. So again, if I look at it like this, if I say square root of n minus 1 and I'm comparing it to the square root of n, it's pretty clear that that's less than that, right? But if I flip it, what's going to happen here?
The sign's gonna change.
It switches. Good. It switches. Now let's talk about comparing the two things. I want us to look at that as a series. 3 over n to the 1/2. Tell me what kind of series that is, guys.
P
P series. And what's P equal to?
1/2.
1/2. P series with P equal to 1/2. Does it diverge or does it converge? Diverges. So let's see what we got here. We got something right here that's bigger than this divergent series. And we started this one at 2, guys. Can anybody see why we started this one at 2? Why didn't we start it at 1?
Because it can't be.
It can't be 1. That I can't. If I put in 1, I'd get 0 in the denominator. So sometimes you have to start your series a little further out. But what happens here is that this thing diverges, and it's smaller than that thing I'm looking at. Well, if this thing blows up, something bigger than it's going to blow up. You see what I'm saying? If you have a divergent on the low end, anything bigger than that's also going to diverge. So by the basic comparison test with this P series, my series diverges. So 3 over square root of n minus 1 diverges. Okay. Let's see one more I got here. Look at this one. Let's take 3n over 2n squared minus 7. And let's drop off the 7. Because you know what I think? If I drop off the 7, I can tell how these two compare. That's got the bigger fraction, bigger denominator. That means it's a bigger fraction. And this is the denominators, this is less than that, so the fraction is like that. Okay? Everybody with me? Everybody agree that that one is less than that one? What is this one if I simplify it?
3 over 2n.
3 over 2n, or 3/2 times 1 over n. Now, look at that as a series. 3/2, 1 over n. Tell me what happens to that series right there.
It diverges.
Why does it diverge?
Harmonic.
It's harmonic. And multiplying it by a constant doesn't make any difference. This is harmonic. It diverges. So what have we got here? We've got this divergent series dominating this, that's like 3 over 2n. So, and actually it's whoa, what happened here? That's, hang on. Let's see, that numerator was less than that. So when I flip it, what do I should get what, guys? Sorry, I messed up here. I should get bigger than right there. There we go. Okay. This denominator right here This right here, if you just look at the denominator, was a smaller number than this one. So if it's less than, it'll flip it when I look at the reciprocal, okay? So what that says is that now I've got this thing is bigger than that thing, and that thing diverges. So that one has to diverge. This one diverges, so that one has to diverge. And I'm comparing it with a divergent series. So you got a divergent on the lower end, you're gonna have a divergent on the something that's bigger than that. Okay. All right, let's hold it right there. I'm getting ready to drastically reduce your homework. I bet you're upset about that. Let me show you what I want your homework to be. And I will try to put this, I'll play out next week. I'll get you an assignment sheet. Here's what I want you to do. I want you to do these problems right here. That's it. So finish your sequence quiz. Go back to that first series quiz I've got. Gave you geometric series, telescoping series, harmonic series. Okay? And then we'll come back and we'll finish this section on Monday. Are we okay? Sort of, so far. Make yourself a cheat sheet. Make yourself a sheet. Remember how I told you to make a list, a card with all the integrals on it? You're doing the same thing here. Make yourself a card with all the tests on it. Here's when a P-series converges and diverges. Here's when a geometric series converges and diverges. Do that and you'll fare much better here. Okay. Anybody got any questions?
Thank you.
Friday. That's a good thing. We made it through another week. Yes? I think we did. We're all here, right? And actually, that means we're halfway through to the end of the semester since we started online. We got 3 weeks behind us. We got 3 weeks in front of us. Okay?
We just need our money, man.
We just what?
We just need our money. Like I need my money.
Oh, you talking about back from Salem? You talking about that?
Yeah. I didn't get no refund check from Trump. He a lie. He a liar. I ain't get no money from him.
It's because you still live with your mama and your daddy or whatever. I don't know. You're a dependent.
That's just crazy. I was waiting for my $1,200.
I know. Anyway, so you will get it back. We've discussed that, guys. That y'all will get the remaining part of your room and your board back. Okay. I don't know
That's
when it'll
so
be.
nice.
Okay. All right. Have a good weekend, and I'll talk to you later. It ain't coming that soon, Alexis. What are you?
It's coming. That's all I'm
Don't celebrate yet. Okay. All right.
It's coming in my bank account.
Okay.
Thank you for these good news.
All right.